Quality control is a critical aspect of manufacturing processes, ensuring that products meet specific standards and customer expectations. One essential concept in quality management is the acceptable quality level, AQL. In this comprehensive guide, we will delve into the significance of AQL, its applications, and how it plays a pivotal role in maintaining product quality. Quality assurance in manufacturing involves the systematic monitoring and evaluation of products to ensure they meet predefined standards. AQL, or acceptable quality level, is a statistical tool used to define the maximum number of defects or deviations allowed in a particular sample of a product. It serves as a benchmark for determining whether a batch of products meets the required quality standards. Selecting AQL, acceptable quality level, and inspection level involves assessing product criticality, production volume, and consumer expectations. Higher AQLs may be suitable for non-critical items, while lower AQLs are crucial for high-quality products. Choose inspection levels based on the desired confidence in detecting defects, balancing sampling costs with quality requirements. What is acceptable quality level, AQL? Definition: the acceptable quality level, commonly known as AQL, is a statistical measurement that represents the maximum number of defective units considered acceptable in a particular sample size. It is a critical parameter in quality control processes, helping businesses strike a balance between cost and quality. Acceptable quality level, AQL, is a standard used in manufacturing to define the maximum number of defective units considered acceptable in a batch or lot. It represents the quality threshold beyond which a product is deemed unsatisfactory. AQL is expressed as a percentage or a specific number of defects per 100 units. Manufacturers use AQL to establish quality control standards, guiding inspection procedures to ensure products meet specified quality criteria. Striking a balance between acceptable defects and production efficiency, AQL helps maintain consistent quality levels in mass production while allowing for some variability to account for practical limitations in inspection processes. Significance of AQL in quality control. Quality control is the linchpin of any manufacturing process, and AQL serves as a powerful tool within this framework. Here's why AQL is indispensable. Cost-effective inspection. AQL enables businesses to conduct efficient and cost-effective inspections. By defining acceptable levels of defects, companies can avoid exhaustive inspections of every unit, saving both time and resources. Risk mitigation. Identifying and managing risks is an integral part of quality control. AQL acts as a safety net, allowing businesses to catch potential quality issues before they escalate, thereby reducing the risk of delivering substandard products to customers. Customer satisfaction. Consistency in product quality is a key factor in customer satisfaction. AQL helps businesses maintain a consistent level of quality, ensuring that customers receive products that meet or exceed their expectations. Compliance with standards. In many industries, adherence to quality standards is not just a best practice but a legal requirement. AQL provides a structured approach to quality control, aiding companies in meeting regulatory standards and certifications. How acceptable quality level, AQL, works. Acceptable quality level, AQL, is a benchmark used in quality control to define the maximum number of defects or imperfections considered acceptable in a production batch. It's a critical concept in manufacturing, ensuring a balance between product quality and production efficiency. Term. Description. AQL. Acceptable quality level, a predetermined quality standard. Purpose. Defines the maximum acceptable defect rate in a batch. Inspection. Sampling inspection method to determine quality. Sampling plan. Outlines sample size and acceptable/reject criteria. Lot size. Total quantity of products in a batch. Acceptance number, C. Maximum number of defects allowed for acceptance. Rejection number, R. Minimum number of defects to reject the entire lot. Inspection level. Determines the sample size and acceptable/reject criteria. Types of inspection levels. 1, 2, 3, generally higher inspection level for smaller lots. Sample size. Number of units randomly selected for inspection. Decision criteria. If the sample has defects less than or equal to AQL, the lot is accepted. If AQL, the lot may be rejected. AQL limit. The maximum allowable percentage of defects in a sample. AQL sets a tolerance limit, expressed as a percentage or numerical value, guiding inspectors to accept or reject a batch based on sampled items. The goal is to maintain a satisfactory level of quality while allowing for some variability in the manufacturing process. A lower AQL indicates stricter quality standards, while a higher AQL permits a higher level of defects. Implementing AQL, a step-by-step guide. Understanding how to implement AQL is essential for harnessing its benefits effectively. Here's a step-by-step guide. 1. Define inspection levels. AQL is based on different inspection levels, ranging from I to 3. Each level corresponds to a different degree of inspection rigor. Choosing the right level depends on the criticality of the product and the acceptable risk level. 2. Determine lot size. Lot size refers to the number of units in a production run. AQL considers different sample sizes based on lot size, with larger lots requiring more extensive sampling. Calculating the lot size accurately is crucial for a representative sample. Example, if a production run consists of 10,000 units, the lot size for AQL calculations would be 10,000. 3. Select AQL limit. AQL limits define the maximum number of defective units allowed in a sample. This limit is determined by the acceptable risk level and the chosen inspection level. Businesses need to carefully select AQL limits based on the desired quality standards. Example, if the AQL limit is 1.5, it means that, on average, no more than 1.5% of the units in the sample can be defective. 4. Random sampling. AQL relies on random sampling to ensure the representativeness of the selected units. The sampling process should be truly random, preventing any bias in the selection of units for inspection. Tip: use random sampling tools or techniques to ensure a fair and unbiased selection process. 5. Inspect according to plan. Execute the inspection plan based on the defined inspection level, lot size, and AQL limits. This may involve visual inspections, measurements, or other quality checks depending on the nature of the product. 6. Evaluate results. Compare the actual results of the inspection with the AQL limits. If the number of defective units exceeds the AQL limit, it may indicate a quality issue in the production process. Real-world application of AQL, case study. To illustrate the practical application of AQL, let's consider a manufacturing scenario. Scenario: a clothing manufacturer produces a batch of 20,000 t-shirts. The company decides to implement AQL to ensure the quality of the products. Steps taken. 1. Choosing inspection level. The company opts for inspection level 2, which offers a balance between rigorous inspection and practicality. 2. Determining lot size. With 20,000 t-shirts in the batch, the lot size for AQL calculations is 20,000. 3. Selecting AQL limit. Considering the criticality of defects in clothing, the company sets an AQL limit of 2.5. 4. Random sampling. Using a random sampling technique, the company selects a representative sample size from the batch. 5. Inspection process. The selected t-shirts undergo a thorough inspection for defects, such as stitching errors, fabric defects, and print quality. 6. Results evaluation. After inspection, it is found that only 1.8% of the sampled t-shirts have defects, which is below the set AQL limit of 2.5. Conclusion: the company can confidently release the batch for distribution, knowing that the quality is within acceptable limits. Calculating acceptable quality level, AQL. Understanding how to calculate AQL is crucial for implementing effective quality control measures. The AQL is determined based on two key factors: the lot size and the acceptable quality limit. The formula for calculating AQL is as follows. AQL equals lot size times acceptable quality limit. AQL in action, real-world examples. 1. Let's consider a manufacturing batch with a lot size of 10,000 units and an AQL of 2.5%. The AQL for this batch would be AQL is equal to 10,000 times 0.025 equals 250. This means that, according to the AQL standard, up to 250 defective units would be acceptable in the batch of 10,000. 2. Let's consider a scenario in the textile industry. A clothing manufacturer produces a batch of 5,000 shirts and decides on an AQL of 1.5%. The AQL calculation for this batch would be AQL is equal to 5,000 times 0.015 equals 75. In this case, the manufacturer would randomly select a sample of shirts from the batch for inspection. If the number of defective shirts in the sample exceeds 75, further inspection or corrective actions would be necessary. The role of AQL in quality management. Acceptance quality limit, AQL, plays a crucial role in quality management by establishing a defined threshold for acceptable and unacceptable product quality. It is a statistical sampling method used to assess the quality of a batch of products before their release. AQL sets the maximum number of defective items that can be tolerated within a specific sample size. By adhering to AQL standards, businesses ensure consistency in product quality, minimize the risk of defects reaching consumers, and maintain customer satisfaction. This statistical tool facilitates efficient quality control processes, enabling organizations to make informed decisions about product acceptance, reject defective items, and continually improve manufacturing processes to meet or exceed customer expectations. Pro tips. Continuous monitoring and adjustment. AQL is not a static metric, it requires continuous monitoring and adjustment. Regularly reassess your AQL standards based on evolving production processes, customer feedback, and technological advancements. Supplier collaboration and communication. Effective communication with suppliers is paramount. Collaborate with them to establish clear quality expectations and regularly assess their adherence to AQL standards. This collaborative approach fosters a shared commitment to delivering high-quality products. In conclusion, the journey toward optimal quality control begins with a deep understanding of AQL and its applications. By integrating AQL into your quality management processes, you can elevate your products to meet and exceed the expectations of your customers, setting the stage for sustained success in the competitive market.